Now that we know how to graph a line using the equations by plugging in points, as we notice, plugging in points, A, is not very efficient, and B, when we get fractions and other things, it actually makes it somewhat time-consuming and wrought with making mistakes. So each line, we have this section 8.3 is going to deal with slope. Slope of a line. Slope is each line has a rate of change from one point to another. And what's interesting about slope is that if we, I don't know why that doesn't work well like that without me having to use this, but we'll deal with it. Let's take a line. Let's make it blue. Let's put some arrows on it. And let's take something like this. There you go. I like that. That's good. So if we look at a couple points, we have this point, we have this point, we have this point. And let's take that point too. So if I wanted to figure out slope, slope is the rate of change of the rise over the run. And when we rise, we go up and down. And when we go up and down, we're talking about the y-axis. And when we run, we go left and right. Left and right deals with the x-axis. So that's the rise over the run. The difference in y's over the difference of x's. So those are a number of different terms that you would explain or describe the difference of y's and x's between 2 points. So let's take these 2 points first. If I could only go up and down and left and right, how can I get from this point to this point? So I'm going to go up, and how many do I go? I go up 2, and oh, excuse me, I'm going to actually go, if I could count properly, I'm going to go 1, 2, 3, sorry. I'm going to go up 3 and right 1, 2, 3, 4, 5, 6. Right 6. So rise over run, how much did I rise? I went up 3. And how much did I run? I went right 6. Up is always going to be positive. Right is also going to be positive. Down would be negative, left would be negative. If we go left on the x-axis, that would be towards negative numbers. So 3, 6, which simplifies to 1/2. So the slope of this line is 1/2. So I picked the two farthest points from each other. There are other points on here, but of the labeled points, I picked the 2 widest. Let's take these 2 points, the most inner 2 points. So if I'm going to go up and down and left and right from this point to this point, I'm going to go up 1 and I'm going to go right 2. Up 1, right 2. Up is positive, right is positive, so my slope is 1/2. What do we notice? It's the same slope. What if I take this point right here? What if I introduce a new point, and let's go from this point to this point? So now we're moving from the right to the left. So going up, down from this point, well, I'm going to have to go down 1, 2, 3, 4. So that's down 4, and then I'm going to have to go left 1, 2, 3, 4, 5, 6, 7, 8. So I'm going left 8. So if I write that, I'm going down 4, left 8. Down is negative 4, left is negative 8. Negative 4 over negative 8 is positive 1/2. So notice each time the slope stayed the same. It is the rate of change from one point to another, whether they are the farthest points or even points that aren't on good grid marks. And you can continue to get as close as you want from any of those points. It will always give you a rate of change of 1/2. I liken it to DNA. It doesn't matter where on your body you pull a sample, a hair from your arm, okay, a booger from your nose, saliva from your tongue, it's always going to give you the same DNA. It is very unique, and it's much like a line. It doesn't matter what 2 points you pull from the line, it's always going to give you the same DNA, which is called slope, and it will always be the same. Part 1, find the slope of the line through the given points. So, knowing that, we have a formula that we can use to help us find the slope. When we're given the line like this and it's on there, we can pick 2 points and we can do the up and right or the down and left, and that sort of slopees. I call that slopees. But when you're just given 2 points, something like 3, 4, and 7, 10, yes, you could graph it. You can take a coordinate plane. You go 3, 4, and 7, 10, and then you can go, okay, how many do I go up? How much do I go right? But that's not very efficient either. We said it was the difference of y's. So there's a formula for slope that says y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that is the formula to find slope when given 2 points. Now, what are these y subs and x subs? Well, we have 2 points here. We have point 1 and point 2. So this is the x value for the first point. This is the y value for the first point. This is the x value for the second point. This is the y value for the second point. So we call that x sub 1, y sub 1, x sub 2, y sub 2. So the first value is y sub 2. That's 10. Minus the y sub 1 value, which is 4. X sub 2 is 7. X sub 1 is 3. 10 minus 4 is 6. 7 minus 3 is 4. And we always have to simplify our slope. And our slope would simplify to 3 halves. So the slope of the line containing these 2 points would have a slope of 3 halves. So here we go. This is going to be my 2 points. This is my x sub 1, y sub 1. This is my x sub 2, y sub 2. So we have y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Y sub 2 is 5. Y sub 1 is 4. X sub 2 is 6. Minus x sub 1 is 8. 5 minus 4 is 1. 6 minus 8 is negative 2. The slope of that line containing those 2 points is negative 1/2. We can see this. That's something we should have talked about. So let's talk about it here. So actually, let me do one. Let's do a graph where it has negative slope, because that will actually create a bit of a dilemma here. So let's do this. So let me pick 2 points. Let's pick this point and this point. That coordinate is negative 2, 8. And this point is 3, 3. So I can go from this point to this point. If I do, I go down 1, 2, 3, 4, 5. So down 5. And right 1, 2, 3, 4, 5. So right 5. So down 5, right 5. Down is negative, right is positive. So I have a slope of negative 1. I could have gone from this point over to here. That would take up 1. I shouldn't have done 1 either. We'll show this. Hopefully it'll work. 1, 2, 3, 4, 5. That's up 5. Left 1, 2, 3, 4, 5. Left 5. So up 5. Left 5, up 5 is positive 5, left 5 is negative 5, which gives us 1 over negative 1, or negative 1. So what I'm trying to show you is that there are 2 different ways to going about it. That negative can be in the numerator or it can be in the denominator. So in this case, if we were looking for points, we can either look at it as 1 over negative 2 or negative 1 over positive 2. So this tells me to go up 1, left 2, or I can go down 1, right 2. In the slope, if we see that on a graph, let's show it. So my point is 8, 4. All right, let's use 6, 5. Doesn't matter. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So to find the next point, I know 8, 4. So 8, 6, 7, 8. 1, 2, 3. 1, 2, 3, 4. So I know that's my line. So if I use my slope, I can use this as my slope, which is up 1, left 2. That would give me a point on the line. Whoop. There you go. I could also, let's delete that, sorry. Or I can use this slope, which is down 1, right 2. And that would get me on the point. So slope can go in either direction when we talk about negatives. For the same thing about, what was my slope? My slope here, let's go back to this one. My slope, remember how I showed that negative 4 down 4 left 8 is the same as the positive 1. So there's lots of different ways. 2 negatives make a positive for positive slope. When you have a negative in your slope, it can also go in the numerator or denominator. I may have just confused you tremendously because part 1 really is just dealing about finding slope when given 2 points. So we have, sorry about that. We have our next problem. Lots of things to talk about. X sub 1, y sub 1, x sub 2, y sub 2. My equation is y sub 2 minus y sub 1, x sub 2 minus x sub 1. My y sub 2 value is 5 minus my y sub 1 value, which is 2. My x sub 2 value is negative 6 minus my x sub 1, which is negative 4. Most students will make their mistake here is they will only write negative 6 minus 4, thinking that the negative in the 4 represents the negative between the two coordinates. That is not true. Please do not make that mistake. 6, negative 6 plus 4, which gives me 3 over negative 2. That negative can go in the numerator or denominator in your final answer, but there's only one negative. Here's some more problems. X sub 1, y sub 1, x sub 2, y sub 2, y sub 2 minus y sub 1, x sub 2 minus x sub 1, y sub 2 is negative 4 minus negative 7 over negative 6 minus negative 8. That's negative 4 plus 7, negative 6 plus 8, which gives me 3 over 2. So my slope is 3 halves. X sub 1, y sub 1, x sub 2, y sub 2. Always label. I always label. It's so much easier when you're writing and you're looking at your values. So I'm looking for my y2. I see it. It's negative 1 minus my y1, which is negative 3 over x sub 2, 3 minus 0. That gives me positive 2 over 3. All right, part 2. Let's see if we can get a little bit more clear and coherent. I'm expanding on this because this is a really important section in algebra. Graphing is very important. You'll see it for the rest of your math career, whether it be geometry, whether it be algebra 2, pre-calc, calculus. So these equations are extremely important. So find the slope of each line. If a line has no slope, say so. So let's just look back here and go through. I want to see what they're doing. So here's an example of using slope ease, taking points and just going. It's interesting that they would do the run first and the rise. I don't do it that way. I always do the rise and then the run. So I would rise 5. I wouldn't say rise. I'd say up 5. I go up 5, and then I'd say left 8. And so up 5 over left 8 would give me positive 5 over negative 8. That's how I would do that. The second part, they teach you the equation y sub 2 minus y sub 1, and that is an opportunity to, when given 2 points. Find the slope of the line with the equation, find any 2 points. So they want you to plug in points. So let's do that, part 2. So we need to find 2 points. So we're going to use our H graph, y equals 2x plus 1, y, x comma y. So easiest point to plug in first is 0. When x is 0, y is 1, so that's 1 point. Let's find another point. Next easiest line is 1, or point is 1 for x. So we're going to plug in 1 for x. We get y equals 2 plus 1, y equals 3. So my other coordinate is 1 comma 3. Now we have 2 points. 0, 1, that's going to be my x sub 1, y sub 1. And we have the point 1, 3, that's going to be my x sub 2, y sub 2. The equation is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Y sub 2 is 3 minus 1 over 1 minus 0, which gives me 2 over 1. So the slope of that line, of that equation, would have a slope of 2. So pretty easy. You're going to do the same thing for each of these equations, and you're going to plug in points, find 2 points, and then use the equation to figure it out. Same thing with these 3. And let's do this one, because what's unique about this one and 23? What do we see about that? It only has one variable. This only has one variable. So we have to be careful. We know that it's going to be horizontal or vertical. So this is where it gets fun. I know I said the word fun. So we make our H chart. When we plug in 0, what do we get for y equals 3? Well, we get y equals 3. So the first coordinate is 0, 3. What if I plug in 1? Well, y is going to equal 3. So my next point is 1 comma 3. That's really cool. Hopefully you see the logic behind that. Remember, I had mentioned that that equation kind of looks like this. So when we plug in 0 for x, you're still getting 0, which is leaving you with y equals 3. So let's find the slope of this equation. We've got our 2 points. We've got 0, 3, which will be my x sub 1, y sub 1. We've got the point 1, 3, which will be x sub 2, y sub 2. My equation is going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Y sub 2 is 3. Y sub 1 is 3. X sub 2 is 1. X sub 1 is 0. We get 0 over 1, which equals 0. This has a slope of 0. Very important. So we know that this line, y equals 3, it's going to cross the y-axis at 3. 1, 2, 3, and it's going to be a horizontal line. Horizontal lines, all horizontal lines have a slope of 0. Very important. Let's look at the last example. X equals 2. So here gets very interesting. Y, X, Y. So we can't plug in 0 for X, because if we plug in 0 for X, you would get 0 equals 2. That would be a false statement. Since it's false, it wouldn't be on this line. What's the only point you can plug in for X? Yes, 2. 2. X equals 2. What's my Y? Well, technically in this problem, we're not plugging in X. We're really plugging in values for Y. So much like this equation, this one really says 0y plus x equals 2. So we are going to plug in for y. If we plug 0 in for y, what do we get for x? 2. What's the other value? 1 for y, we get x equals 2. So my coordinates are going to be 2, 0, 2, 1. A little advanced, a little going to definitely stretch your brain a little bit That's the only time that we would plug in for y. You could plug in for y for these equations. You could plug in for y and solve for x. Traditionally, we plug in for x. Don't know why. It's just the way that they do it. So here are my 2 points. We have 2, 0, and we have 2, 1. That's going to be x sub 1, y sub 1. This is going to be x sub 2, y sub 2. My equation is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Y sub 2 is 1 minus 0 over 2 minus 2, which gives me 1 over 0. What's wrong with that? Yes. 0 is in the denominator. When you have 1 over 0, that is no solution. When it's no solution, that means there is no slope. That is my answer. No slope. What type of line is this? That is a vertical line. It says x equals 2. 1, 2. It's going to cross the x-axis at 2. So when we have vertical lines, it has no slope. All vertical lines have no slope. Horizontal have 0 slope, no slope. That line is going to have negative slope. It's going down left to right. This line is going to have positive slope because it's going up left to right. So those are the 4 different types of slope. Negative, positive, 0, it's flat, it has no slope. It's like a ski, right? And then this one is death on a ski slope, right? So no slope. You wouldn't want to ski that. All right, last part. Section 8.3, part 3. Through the given points, draw the line with the given slope. So we have a point, and we have to plot that point because the slope is 4. So let's look at that. Slope of 4. 4 is a fraction. Remember, it's rise over run. So it's positive, so we're going to go up 4. Run is left and right. That's positive, so it's going to be right 1. And again, I call that slope ease. So I don't know where I'm going to go up 4, right 1 from. So I have to first plot a point. 3, 2. 1, 2, 3, 1, 2. So here's my point. Now I can use my slope, which tells me from one point to the other, we're going to go up 4, 1, 2, 3, 4, right 1. So there's a point. Up 4, 1, 2, 3, 4, right 1. Now what's the opposite of that? Wouldn't negative 4 over negative 1 give me this? Yes, it would, right? If we look from this point to here, we would go down 1, 2, 3, 4, left 1. So if I run out of space going up, I can go 1, 2, 3, 4 down over 1. Does it stay on that line? It does. Slope will be consistent in that manner. So there's my line. Drawing a line, given the slope and that point. Here's the point, 2, negative 7. 2, 1, 2, 3, 4, 5, 6, 7. 2, negative 7. I have a slope of 0. What does that mean? What's 0 as a fraction? 0 over 1. So what does that mean? That means up 0 and then right 1. So I'm going to go up 0 from this point and right 1. Up 0, right 1. I got 3 points. I have a horizontal line. And remember, horizontal lines have slope of 0. So that would be the graph of that. What about this one? So I'm going to plot my point first. Negative 3, 1, 2, 3, positive 4, 1, 2, 3, 4 is right here. I have a slope of negative 2. Negative 2 is a fraction, is negative 2 over 1. I'm up and down, so negative is down 2. Positive 1 is right 1. So I'm going to go down 2, right 1, down 2, right 1, down 2, right 1. What's the opposite of that? I could have put the negative in the denominator, and that would be up 2, left 1. Left because it's negative. So up 2, left 1 would give me here up 2, left 1. Notice it stays on the same slope. Ah, look at that little problem. My point is -5, 1, 2, 3, 4, 5, +1. I have a slope of -1/2. Notice the negative isn't in the numerator or the denominator. So I can choose. I can choose for it to be in the numerator, or I can choose for it to be in the denominator. It cannot be in both. There's only one negative, so either way I go, there still has to be one negative. So I can go down 1, right 2, or I can go up 1, left 2. Notice it keeps the same slope. Love that problem. When I said part 3 was the final part, that there would be a part 4. Typical jinx. Points that lie on the same line are said to be collinear. That means all the points are on the same line. They lie on the same line. Determine whether the given points are collinear. So we're going to plot those points. 1, 4. 1, 1, 2, 3, 4. 3, 0. 1, 2, 3, 0. And 5, -4. 4, 5, 1, 2, 3, 4. So can I connect the dots with a line? Do they connect all? Yeah, those are collinear. They are all lie on the same line. A line can contain all 3 of those points. So yes, determine. So one way is by graphing. That is the easiest way, but when we get points that are super far away, so what we could do, another technique, is find the slope between those 2 points. So it's going to be y sub 2 minus y sub 1, x sub 2 minus x sub 1. So I get -4/2 or -2 as my slope between those 2 lines. Now I'm going to find the slope between these 2 lines. So y sub 2 minus y sub 1, x sub 2 minus x sub 1, we get -4/2, which equals -2. And then we have to do one more. We got to do between these 2 points. So I would test those out, and I get my y sub 2 minus y sub 1, and x sub 2 minus x sub 1. I think that's right, yep. That gives me -8/4, which is -2. Notice all 3 of those relationships between the points all have the same slope, so that would also be a determinant on whether they are collinear. We try this. So let's try these 2 first. 5 minus 1, 6 minus 8. That gives me 4/-2, which is -2 again. Wow. Let's take these 2. 8 minus 5/4 minus 6. That's 3/-2. Aha! What do we notice? Not the same slope. So, not collinear. So if I plotted those points, and let's test that out. Let's see what it looks like if we put it on a graph. Let's move you guys over a little bit. Let's move this there. So let's plot those points. So the point is 8, 1. That's going to be right here. 6, 5. 6, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, and 4, 8, 1, 2, 3, 4, 1, 2, 4, 8 is here. Wow, that looks really close, but look at that. If we take a line and try to connect them, right, I can connect those 2. Notice that point. I can try to connect those 2, and notice the other point, the third point is not, and then I can connect these 2, and notice that point is not connected. So, oh, I didn't mean to do that. Delete that. Let's pull, if I pull these away. So if I try to connect, that's that line. So notice this line, that point's missing. These 2 points, that third middle point is not on it. And then this one, notice that third point is not. So those are not collinear. Points that lie. So we can do that again for the third one. Let's do these 2 points. 1 minus 9, negative 1 minus negative 5 gives me negative 8 over 4, which is negative 2 again. Wow, I love that slope, don't they? Let's try these two. Negative 4 minus 1, 1 minus negative 1. That's negative 5 over 2. Those are non-collinear, not collinear. Not collinear because their slopes are not the same.